Okay, recording now. This is lesson 5.1 on mixed numbers and improper fractions, as well as a review of how to reduce fractions to its lowest terms. Before watching the recording, please make sure that you have a graph sheet of paper in front of you and that you've written today's date and the title 5.1 at the top of your page. Now, you may need to pause the recording now to get those items. Also, note that I've already written some things here on the page that you should have too. So you should take a moment to pause, get all those items, and write down what you see here. And then I will continue once you've caught up. Okay, so moving on. The first thing that we'll talk about is reducing fractions to lowest terms. So we're going to simplify. Now, hopefully by now, you've written down what we have here at the top. What we have here at the top is some important vocabulary that you need to remember. The top number of any fraction is called the numerator. The bottom number of any fraction is called the denominator. Again, the top number is the numerator. The bottom number is the denominator, and I'll be referring to those terms throughout the video, and you should always remember that when we're thinking about fractions too. Okay, so continuing on, the first review point that we'll cover here is how to reduce fractions to lowest terms before we get into mixed numbers and improper fractions. Okay, so I'm going to take that example up there, so 4/8. So a couple of things to keep in mind when you're reducing fractions to lowest terms. So please jot these down. The first thing is you're always going to access your divisibility rules. This is an example of how things always spiral and connect in math, okay? The other thing that you're going to remember is remember to access the greatest common factor. You're always going to think about what is the GCF of the numerator denominator. So what is the greatest common factor that the numerator and denominator can divide into? You're also, again, applying your divisibility rules here. So it's a good time to review these as well. If we look at 4/8, we want to get that to the lowest possible terms. And I'm thinking in my head, I know 4 and 8 are both divisible by 2 because they both are even numbers. So what I do is I just show that the numerator is divided by 2 and the denominator is divided by 2. My result is going to be 4 divided by 2 is 2. And then 8 divided by 2 is 4. Now, I use this as an example because sometimes you can't get the GCF right away. I noticed that 2 and 4 they still can divide evenly by 2 because they are both divisible by 2 because they are both even numbers. Okay, now, a lot of you I know can jump to the first step already where you can go 4/8 can reduce to 1/2, but I'm breaking this down so that I know that 1/2 is the lowest 4/8 can go, okay? Now, I want you to do the next one on your own. So I will give you, let's say, 12/36, okay? So again, think to yourself, what is 12 and what is 36? What are they both divisible by? Or maybe you can jump ahead to the GCF. Okay, so pause the recording and simplify 12/36 on your own right now. Okay, I'm going to continue. I'm going to jump ahead because I know by looking at the ending digits of both numbers, they are both even numbers. I know that 12 can ends in a 2, and I know 36 ends in a 6. Therefore, they're both divisible by 2 because both of the last digits are even. But I know also in my head that, I think accessing my multiplication tables or my times tables, I know that both the numerator and the denominator have a GCF together of 36. So you can actually divide both the numerator and denominator by 12, which means our result is 12 divided by 12 is 1, and 36 divided by 12 is 3. So simplified, 12/36 goes to 1/3. Now, if you can't do that right away, you can simulate the steps I have here. If you know that 12 and 36 are both divisible by 2, you keep breaking it down until there is no more common factor that the numerator and denominator can be divisible by. So that's a quick review as to how to get the lowest terms of a fraction, because you might encounter that with some of these examples. Okay, moving on. So we're going to talk about mixed numbers and improper fractions. Okay, so let's start with vocabulary first. Okay, so a mixed number is where you have a combination of a whole number and a fraction. And a fraction. Again, a mixed number is where you have a combination of a whole number and a fraction. So make sure you jot down that definition. Okay, so an example would be, you can come up with any example you want. I can say, when I write my next mixed number, by the way, the whole number, make sure it's significantly bigger than the fraction. So you notice the scale I'm doing here. So 11 and 4 sevenths. Okay, so that would be an example of a mixed number. Another mixed number could be 2 3/4. Notice again, the whole number part is bigger, written significantly bigger than the fraction part of the mixed number. Okay, now we have improper fractions. So this is where the numerator is bigger than the denominator. So notice I'm throwing in the vocabulary here. So meaning that the numerator, the top number, is bigger than the bottom number, the denominator. Okay. So examples for that. You could have 79 over 7. You could have 11 over 4. Okay. So notice again, in both of these instances, the top number is bigger than the bottom number. So the numerator is bigger than the denominator. That's why it's called improper. Typically, what you may have seen up to now is that the denominator is bigger than the numerator, but you can have improper fractions where it's the reverse. Okay, so the main goal of this lesson is to learn how to convert mixed numbers to improper fractions and also how to convert improper fractions to mixed numbers. I'm going to start off with sort of the easier way, which is going from a mixed number to an improper fraction. Okay, so how to convert, so jot this down, how to convert mixed numbers to improper fractions. So again, I'm just going to do this straightforward numerically, and I'm not going to use manipulatives here, but in a later lesson we may go back to manipulatives just so you understand the process. Okay, so how to convert mixed numbers to improper fractions. So remember, mixed numbers, when you have a combination of a whole number and a fraction, and an improper fraction is where the numerator is bigger than the denominator, as described above. So here's an example. Okay, say I would like to convert the mixed number 4 2/5, okay, and I want to convert that to an improper fraction. So the process is the following, and I want you to jot this down on your page too, is that what you're going to do is you're going to take, and I'm going to highlight, you're going to take the denominator, okay, and then you are going to multiply it by the whole number, okay? So that's what that arrow signifies, and that multiplication symbol. Again, you're going to take the denominator, 5 in this case, you're going to multiply the whole number by 4, multiply it by the whole number, and then you're going to add the numerator to it, okay? So again, you multiply, in this case, 5 times 4 times the whole number, and then you add the numerator. So your result, 5 times 4 is 20 plus 2 will give you 22. Now, you always keep the same denominator, okay? So the denominator stays the same. Okay, so let's write down what we just did. So to convert mixed numbers to improper fractions, what you need to do is you need to multiply the denominator by the whole number, then add the numerator. And remember, your denominator stays the same in both cases. Okay, I'd like you to do an example on your own here. Okay, say you get, you have, say 5 and 2/9. So what I'd like you to do is convert 5 and 2/9 into an improper fraction. So pause the video and see if you can do this on your own right now. Okay, otherwise I'm going to continue. Remember what I said above? The first thing actually, which I should have done earlier, is remember that your denominator stays the same. So I'm going to recopy 9. I'm going to follow the same process as described above. I'm going to multiply the numerator by the whole number. The denominator by the whole number. So 9 times 5, which is 45. And then I'm going to add 2 to my answer. So 9 times 5 is 45 plus 2, which gives me 47. So my result is 47 over 9, okay? Okay, so that's the process of converting mixed numbers to improper fractions. All right, now let's move on to B. Part B is how to convert the other way, which is a little bit trickier, but you are going to access your skills of long division here. How to convert improper fractions to mixed numbers. Okay, so jot that down. Again, how to convert improper fractions to mixed numbers. Okay, so it's best to describe this or explain the process using an example. Say I had the improper fraction of 17 over 2. So remember, an improper fraction is where the numerator is bigger than the denominator. So what I'm going to do is I'm going to access my skills of division, right? So what I'm going to think to myself is, okay, so I'm going to get the biggest whole number here. So I'm thinking 17 divided by 2. What will give me the biggest whole number without going over? So kind of you're accessing your skills of division here. So I know the closest whole number I can get to is 8. Because I know that 8 times 2 will give me 16. Okay, so whatever the remainder is becomes the numerator of the fraction. Like in the process described above from mixed numbers to improper fractions, you are going to keep the same denominator. So in this case, it's 2, right? So remember, and I should have said that first, the denominator always stays the same, okay? Now, if 8 times 2 is 16, how much more do we need to get to 17? So how much more do we have to add to get to 17? We know we have to add 1 to get to 17. Now, the great thing about this is that you can check your work to see if you're correct by doing the reverse process. How do I know I'm right? Well, I know that if I multiply the denominator by the whole number, and if I add the numerator, I should get 17. So 8 times 2 is 16 plus 1, which is 17 over 2, so I know I'm correct. I'll do another example with you before you can do one on your own, but if you want to pause the recording and figure out the next example on your own, go ahead and do so. The next one will be 100 over 9. So again, if you want to try this on your own, you can. If you want to do this one with me, go ahead and I will walk you through it. So again, I'm thinking to myself, what is the closest whole number? So if I did 100 divided by 9 in my head, what is the closest I can get to 100 without going over? So how many times can I multiply 9 by to get to 100? Again, I'm accessing my multiplication tables. I know that the closest I can get is probably 99, which means 9 times 11 will give me 99, which is pretty close to 100. So 11 will be my whole number. Now remember that again, we keep the same denominator, right? The same denominator in each case is going to be 9. And then so I know 9 times 11 will give me 99. So my remainder is 1. And that becomes the numerator of the fraction. How can I check that I'm right? Again, I multiply 9 times 11, which is 99, plus 1, which will give me 100. So therefore I'm correct. We should summarize this process too before I give you one more example to try on your own. So to convert improper fractions to mixed numbers, you divide the numerator by the denominator, then the remainder is the numerator of the fraction. Now, be careful to make sure in all of your cases that fraction part of the mixed number is a proper fraction. Some mistakes that have been made in the past where you end up with an improper fraction in the mixed number. So just make sure that in your mixed number, your numerator is smaller than the denominator. And again, there's a process where you can check it. Okay. Let's do one more example where actually you can do this on your own. Okay, this time let's do 10 over 6. Or you do 10 over 6 and you figure out, okay, how do I get that to a mixed number? So again, pause the recording and try to do this on your own. Okay, I'm going to continue. So I know, again, how I should set it up is, I know that the denominator is going to be the same. Okay, so I know it's going to be something over 6. So I'm thinking 10 divided by 6, approximately how many times? How many times can I multiply 6 to get to 10 without going over? The closest I know is probably only going to be 1, okay, because 1 times 6 is 6. My remainder, how many times do I have to add to get to 10, is going to be 4. Okay, I'm going to check my work. So I know that 1 times 6 is 6. Okay, plus 4, which will give me 1 and 4, 6. Now, here's another thing that I want to connect to what we started off with at the beginning of this lesson. We were talking about lowest terms and reducing fractions to lowest terms and simplifying it. So you could get a question where, okay, reduce your final answer to lowest terms or simplify it. Because I know that when looking at this, for the numerator 4 and the denominator 6, they can be divided further because they are both divisible by 2 at least, right? So to reduce this to lowest terms, I know I'm going to keep the whole still because the whole number stays the same. Now, I look at this and I go, okay, I know because of my divisibility rules that both 4 and 6 are divisible by 2, and that is also the GCF of 4 and 6. 4 divided by 2 is 2, and 6 divided by 2 is 3. So, therefore, this is the fraction 1 and 2/3 reduced to lowest terms. Okay, so just keep that in mind too. So we got 10 over 6 first. We know that we're thinking in our head, how many times can 10 divided by 6 in our head, approximately how many times can we multiply 6 to get to 10 without going over? We know it's once, so the whole number is 1, okay? The remainder is 4, which becomes the numerator of our fraction, so we have 1 and 4, 6. We did our check, we know we're correct. But the question can further ask you, please simplify the fraction to lowest terms, so that's how you get 1 and 2/3. Okay. And that is it for 5.1 mixed numbers and improper fractions, as well as a review on how to reduce fractions to lowest terms.